Welcome students. Welcome back to our online class. Now today's class we are going to discuss about application of electrolysis. Electrolysis has several technical and commercial applications, and in our today's world it is even more widely used to beautify our articles, things, and to increase the life of articles. Most common applications of electrolysis are electroplating with metals. Number 2, electro-refining of metals and extraction of metals, which is also called electrometallurgy. So these three applications of electrolysis we are going to study in our class 10 syllabus. And in our today's class we will be discussing about the first application, and that is electroplating with metals. What is electroplating? Electroplating is a process in which a thin film of a superior metal is deposited on another inferior metal with the help of electrolysis or electric current. Here, superior metal means those metals which do not rust easily, which do not corrode easily, and which provides luster or shine to the article. Whereas inferior metal means those metals which rust easily, corrodes easily, and they are dull in appearance. So the main idea over here in the electroplating is to deposit a thin film of superior metal on another inferior metal with the help of electrolysis or electric current. Now some of the examples of superior metals are gold, silver, nickel, chromium, etc. So with these metals we can plate on inferior metal, and that process is called electroplating. Now why there is a need for electroplating? Electroplating is done for decoration purpose. For example, brass articles are plated with silver to give them shining appearance and beauty. So electroplating is done to increase or enhance the beauty of any given article. The second reason for electroplating is to provide protection from rusting and corrosion. For example, iron articles can be easily rusted or corroded when exposed in air. Therefore, iron articles are electroplated with nickel, chromium or zinc to protect against rusting and hence increasing the life of the article. Now, let us see what are the different conditions required for electroplating. Now for that, we have over here electrolytic vessel where we can carry electroplating process. The positive terminal, which is shown as yellow electrode, is the anode, and the negative terminal, which is shown as green electrode, is the cathode. These two electrodes are connected to an external terminal source of current, which we can use a battery, which has a key. The role of the key is to connect the external circuit so that there is a flow of current. To that external circuit, an ammeter, which is denoted by A over there, is also attached so that we know that there is a flow of current in the external circuit as well as the internal circuit, which here is the electrolyte. Now let us see one by one the different conditions required for electroplating. The first condition is the article to be electroplated is always placed at the cathode. So the article which needs to be electroplated with superior element metal is kept at cathode, which is a green electrode. So the inferior metal is kept at the cathode. The second condition is the metal to be plated on that is the superior metal. The metal to be plated on the article is always made anode, and it has to be replaced periodically. So the anode is made up of superior metal, okay, and the anode needs to be replaced periodically. The reason behind the periodical replacement of anode is, as the electroplating process continues, the anode becomes thinner and thinner and thinner, and there will be one point where there won't be any anode left, as a result of which the process of electroplating stops. Hence, to continue the electroplating process, we need to replace anode periodically. The third condition is the electrolyte must contain ions of the metal which is to be plated on the article. That is, the electrolyte must contain ions of superior metal. So electrolyte containing ions of metal is to be there in the electrolyte solution. Fourth condition is there has to be a flow of current, but the current has to be low current. It should not be high voltage current, it should be low voltage current. And the current has to pass for a longer time in order to make sure that the electroplating is smooth and even. If the current is passed very rapidly for a short period of time, then the plating, the plating will not be thin, it will not be smooth, and it will not be even. Therefore, to have a good electroplating, the current must be low and it must be passed for a longer period of time. It should be a slower process. And the last condition is, last condition is the nature of the current has to be direct current. It should not be alternating current. If the alternating current is passed, then the discharge of ions will be alternate, as a result of which there won't be proper electroplating. They will not get the desired electroplating. Hence, the current has to be in one-way direction, which is a direct current. Now let us take one example of electroplating. Electroplating an article with silver metal. Now this is an arrangement in the electrolytic vessel. Now the cathode is made up of inferior metal, or at the cathode we place the article on which we need to do electroplating. For example, here we have taken a brass spoon. So we want to coat this brass spoon with silver. So here anode needs to be made up of block of pure silver. So this anode now will get deposited on the cathode, which here is made up of brass spoon. Now let us see the electrolyte that we need to take in order to do this electroplating with silver. The electrolyte we take over here is solution of sodium argentocyanide. Sodium argentocyanide, and the formula is NaAgCN2. So this silver argentocyanide is preferred as the most suitable electrode in the electroplating of an article with silver. Now let us see the ions present in this electrolyte. Now sodium silver argentocyanide ionizes into Na plus ion plus silver ion and cyanide ion, whereas the water molecule dissociates to form H plus and OH minus ion. So we have three types of cation. They are sodium, silver and hydrogen or H plus ion, whereas we have two types of anions. Now let us see the reaction taking place at the cathode. Now at the cathode we know what type of reaction takes place. At the anode there is gain, at the cathode there is gain of electron, GR, so reduction. So at the cathode the silver ions, because among the cations silver is most readily discharged, therefore silver ion cation moves towards the cathode. It will gain one electron at the cathode, which is made up of brass spoon, and the silver atom gets deposited on the cathode, which is a brass spoon. Now let us see the reaction taking place at the anode. Now before seeing the reaction at the anode, let us see which ions migrate towards anode. The anions migrate towards anode, and we have two types of anions. They are cyanide ion and hydroxide ion. Now both these ions will move towards anode, but the anode is made up of silver. It is again a metal. Now the nature of the anode does not allow cyanide or hydroxide ion to release their electron to the anode, because metals, they do not receive electron, they give electron. Therefore neither cyanide nor hydroxide ion gets discharged at the anode. Instead, what happens? The anode itself, the silver, will give or lose electron and converts into silver cation. So here the anode ionizes or loses electron and converts into silver cation. So the silver cation produced by anode enters into the solution, electrolyte solution, okay, and replaces or fulfills the loss of silver cation from the electrolyte solution. Thus the equilibrium of lost silver ion is maintained by the release of silver ion from the anode, due to which the anode with the passage of time becomes thinner and thinner, and hence we have to replace the anode. Now sodium argentocyanide is preferred over silver nitrate solution. Now we can also use silver nitrate solution to carry the electroplating of silver, but it is not the most preferred electrolyte. The reason behind that is silver nitrate solution decomposes very fast, giving silver ion cation and the nitrate anion. So this rapid or fast decomposition of silver nitrate to silver cation and nitrate anion makes the plating fast, due to which the electroplating will not be smooth and uniform. But the sodium argentocyanide decomposes slowly, and hence the plating of silver on the brass spoon becomes very smooth and uniform, and hence the purpose of electroplating is met. Now in the same way, there is another example in your book. The electroplating with nickel is given in your book. I want you to go through that process. Note the electrolyte used, note the anode used, the metal with which anode is made, and the reactions taking place at cathode and anode. And relating to these two electroplating, your today's assignment is made. which you have to complete and submit on time for its timely review. So the assignment for today's class is question number 1. Answer the following question based on electroplating of silver on brass spoon. So there are A to F questions in question number 1, and question number 2, in respect to the electroplating of knife made of iron with nickel, answer the following questions A, B, C. So these are the questions as your assignment for today's class. Please go through your book also. Please watch this video nicely. If you have any doubt, please, you are always free to call me at my WhatsApp number, or you can even mail me. This much for today, boys. I hope I have made you understood electroplating. Stay safe and do all things well.